processes that are happening with your eyes. Because, well, you see everything. Your primary sense is seeing, sight, right? So, are you recording?
Yep.
Oh, okay, so when we talk about light spectrums and seeing lights, when we look at a handbag, or if we look at a piece of paper, or if we look at the table, looking at this marker, looking at this red one here, why do you see the marker here? What's hitting your eye?
Light.
Light, what do we call it? Photons. Photons. So in other words, you have some sort of thing hitting this pen. It's absorbing all kinds of spectrums, but it's not absorbing which color?
Red.
Red, which is being reflected back to your eye. Does that make sense? And what part of your eye actually picks up that?
The rods.
Not the rods.
The cones.
The cones. The cones. The cones pick up color.
Yeah.
The rods pick up what?
Black and white.
Black and white or shades. How do they know that animals, or actually how do they know that anything that is not an ape can't see color? They don't have any cones. So when they say dogs can't see color, they didn't actually put themselves in the seat of the dog and say, oh, I can't see color. They actually looked at the biological means, and they saw, oh, they don't have any cones, therefore they can't see color. So their eyes.
Other animals have, like, they don't have them to, like, the cats have some cones, but not to the same extent.
To the same extent, right. And then also some creatures like the mantis shrimp can see ultraviolet, where our eyes can't see that, you know? So it's whatever kind of receptor you have, you can see those kinds. What do they have? They have thermal imaging for certain animals. They can see infrared. You always give off infrared. You just can't see it. Your body's always emanating all these different kinds of electromagnetic waves, which are in the form of photons. So we just said that light was a nice little happy-go-lucky photon packet, right? And he's just zipping through space in a sinusoidal wave. It flips up and down through space, and then it hits things, right? It hits your eye. And you say, ow, right? Hits you in the eye, and you're like, ow, that hurt. But you saw that this was a red wavelength because of the distance that this guy was traveling, the wavelengths that they were, or the frequencies. Okay, so light comes to you in the form of photons. Any questions so far on this?
I have a question.
Yeah.
Why do they usually say that the rays travel in straight lines? Sometimes they do the waves, like...
That rays travel in straight lines?
Yeah.
Okay, so that is correct. It does travel in a straight line. It does travel in a straight line. However, that straight line is the average between the up and down motion. Okay. So that is correct, though. However, the longer wavelengths, the ones that take longer to actually oscillate through, can be bent. And that explains why during a sunset you see red. Red is a longer wavelength than blue. So when you have the sun underneath the earth, the blue is being shot off at a straight line, but the red is being shot and then bented slightly, and you see the red as a sunset. So the longer wavelengths can be bent, and that's what you're seeing there. So when you guys had your fireworks show and stuff like that, you had photons being bombarded against your eyes, and those photons were being emanated from chemical reactions that occurred. So you had some sort of chemical reaction that shot out a photon. But those photons, if you remember in an atom, we said that there's a proton, there's a neutron, there's an electron. We didn't say anything about a photon, did we? No. No. So what's happening there is when you have an atom, here's the nucleus, and then around it you have your electrons, right? And we're going to say it's one electron. Right there. What happens is this guy, for whatever reason, gets super excited. He'll bump up to a second energy level from the first, and he'll bump up to the second one. So he bumps up there. Now that he's up there, is there anything down on this energy level since he moved from there? No. And remember, everything in life likes to be at its lowest energy state. So since it gained energy and bumped up, what's going to happen when it's back over here and it wants to go back down? It's going to end up doing what? It's going to release that energy. and it's going to release that energy in the form of a photon. And that's what you're seeing, is those photons, those electrons getting excited, and then dropping back down, they release a photon. These lights that you see here, they're releasing all kinds of photons. All the photons that you're seeing hitting your eyes at one time, all the reds, blues, yellows, greens, all those frequencies together is making the white that you're seeing. So does that make sense so far? Any questions on how photons are working? Okay. So there's going to be a few equations that you're going to need to know, obviously. Otherwise this would be a chemistry class. It would be a philosophy class. Probably be funner. I would love to have a class where you don't have to do any kinds of calculation, you just talk about it. That'd be cool. You know?
Had those classes.
I would love that. Not have to worry about the students getting bad grades. Like, yeah, let's chill, let's talk about it. Yeah.